Hello dear students, welcome to the lecture 1 of Introduction to Programming 2. This course was named previously as Advanced Programming. We are going to see this course with C#, so therefore you have to have basic knowledge about programming with C#. If you don't have, you can see our Introduction to Programming course material here. Introduction to Programming 2020, and also you can watch our Introduction to Programming course video series on our YouTube channel. Our YouTube channel name is SA Courses, Software Engineering Courses, and on the playlist you can see our first semester lecture Introduction to Programming full course with C#. So if you don't know how to do programming, if you don't have the related knowledge, you can watch all these 14 videos and then you can continue our Introduction to Programming 2 course. The name change is coming from our department name change. We were software engineering and we were computer and software engineering. Now we are only software engineering. Therefore, we have made some course name changes. However, it is same as previous advanced programming. So don't get confused with the name Introduction to Programming and Introduction to Programming 2. Okay. So for those who doesn't know, I am posting all the course materials on GitHub. So please follow my courses from GitHub and YouTube. As for the LMS system of the school, I won't be using it a lot. So everything will be posted on our GitHub repository here. This is the URL of our GitHub repository, and on our YouTube channel here, SA Courses. I will compose a playlist for Introduction to Programming 2 as well. So you can see our existing playlists here from the previous semester. Okay, as for the course, I will be using Visual Studio Community Edition latest version. After a certain point, Microsoft changed .NET Core name to .NET. So let's start with creating a new project. Meanwhile, I will also compose our folder. Okay, to 2021. Okay. All right, so we will be using VPF.NET and console.NET. You see, VPF.NET is actually VPF.NET Core, but it is now named as VPF.NET, and the classical .NET is named as .NET Framework. As for developing applications, there isn't much differences. However, .NET Core, now named as .NET, is newer version, and it will be used from now on. It will be developed further. It is the newest technology. It is better. So let's start with composing our first application. Okay, we have selected our folder and I am going to name it as lecture 1. Okay. Okay, now composing the project. It is the VPF.NET, previously known as .NET Core. So don't get confused. If you also install the newest Microsoft Visual Studio Community Edition and update it to latest version, you will also see the naming that as well. Okay, I will show you my version here. Okay, so you see it is this version 16, 8 and 6. Okay. Okay, now it is building our application. As for the first lecture, we will start with some uh, remembering of the previous semester. So, how we were able to write methods. First, we define the return type of the method. It can be void or it can be any parameter. So this will be a void method. And before it, we can define it is static or not. It is static or instance method. So let's write several methods and see all of them. Then after we define the return type, we write the name of the method, such as first, or let's name it as method 1. Then we write the constructor of the method, and here we define the input parameters. It is also defining the signature of the method, such as int param1 and let's say double param2. Then we open and close the curly brackets like this. And one more thing there is, it is private or public or protected. So this is private static method. Private means that it can be only accessed by the methods under same parent class. So what is the parent class of this method? It is this one. It is the main window class, which is inheriting from window class. We will see about inheritance in the next semester, but I may also explain in this semester as well. By the way, you can also watch the next year's course, which is object-oriented programming. Here, it can be also useful for you, but we will see that in the next semester as well. It is the course of the second year at the university. Okay, so private means that it can be only accessed by the methods under same parent class. So let's define another method. This time let's make it protected. Method 2. So you see, when I define it like this, it is throwing me an error because same name method exists with same signature. Okay. However, if I add here something else, it would work, but don't get confused right now. So we will see about method signatures later. Okay, so let's call this as method 2. Protected means they can be only accessed by, if I remember correctly, it is same DLL. But let's remember. Oh, it was not protected, but it was the other one. Okay, so I was remembering incorrectly. Okay, let's write it like this. I think I will copy and paste this. Okay. Okay. Okay, so protected means can only be accessed from within the same parent class here, main window, and any object that inherits of the class. Okay, so when we come to part inheritance, we will see that. So if I compose another class which inherits main window, I can access the protected method. I can access the public method, but I cannot access private method. Private method can only be accessed within the same parent class. And then we have public. Okay. Now then we will see the initial instance instantiable classes. I think it's hard to pronounce. So when I make it like this, now I have to have an instance of this method. How can I have instance of a method? You can have instance of a method by composing an object from its parent class. Okay, so let's say I have another class here. I will edit. Okay, let's name it as instance example. Okay, now I can access the static and public methods of main window. Let me show you. Okay, let's make it private. Let's make this return type having. So this will return an integer value. Method 11. Okay, now let me show you what I can access. So from main window, I can access method 3. Okay, why only method 3? Because method 3 is static and public. Therefore, I can access it like this. However, I cannot access the other methods. This is method 4 is also public, but I am not able to access it. Do you know why? By the way, method 3 is taking 2 parameters, so therefore I will give them 0 and 0 like this. Okay, so if I want to access, by the way, it has, this one also has to return something, so it will return 0 in this case. If I want to access method 4, what do I need to do? To be able to access method 4, I have to define an instance of main window like this. My another window equal to new main window. Now I have an instance of main window class. You have to have instances of non-static classes and methods to be able to use them. Okay, now I can access method 4 of main window class. Okay, so you are to be able to understand this, you should practice. So this is the what is about static and non-static. To use non-static methods, you have to have instance of the class that has that method. Okay, or same rule applies to methods, classes, and other objects. So here basically we have created an object of main window class. We have composed an object of main window class, and then we can access the non-static methods. However, they have to be protected. I mean public non-static methods of that class as well. I can still when we check, you see method 3 is not available because method 3 is not instance having a method. It is a static, therefore I cannot call method 3 of this instance. However, I can call it directly as main window class. Like here, let me show you. Like here, even though main window is not a static class, the .NET handles that part, and make its static methods available to us. Okay, this is a good thing. And now we have remembered what are public, protected, private, what are static and not, and what is void and return type having methods such as it can return anything, any class. Let me show you an example. So I will define a class here. Let's name it as car class. Okay, this is a classical example. Class car. So class car is by default private, and these methods now can return car type. Okay, so for it to work, I have to compose a car type object. My object, let's say my car, equal to new car, and return my car. Okay, and now this method will work. However, I have to change its name because its signature is same as previous. So let's see about signatures as well. Okay, so there is an inconsistent accessibility. So this method is public, however, this class is private. Therefore, the .NET is telling us that you have inconsistent accessibility. Either I have to make this public or I have to make this private. So let's make this private first. Now it works as expected. However, now I have to change its signature. So the signature of this method is integer and double. Does the order matter? Let's see. So if I make it double and integer, now it works because signature of this method is double and int. This is also called as method overloading. Different signatures having same name it methods, or let's put it differently. If you define methods with same name but different signatures, it is called as method overloading. Let's find the formal definition. Okay. Okay, with method overloading, multiple methods can have the same name with different parameters. This is not much formal definition. Okay, let's read this definition.
Method overloading is the common way of implementing polymorphism. It is the ability to redefine a function in more than one form. A user can implement function overloading by defining two or more functions in a class sharing the same name. C# can distinguish the methods with different method signatures. I.e., the methods can have the same name but with different parameters list, i.e., the number of the parameters, order of the parameters, and data types of the parameters within the same class.
Okay, so this is the description. Let's read it more.
Overloaded methods are differentiated based on the number and type of the parameters passed as arguments to the methods. You cannot define more than one method with the same name, order, and the type of the arguments. It would be compiler error. The compiler does not consider the return type while differentiating the overloaded method. But you cannot declare two methods with the same signature and different return type. It will throw a compile time error. If both methods have the same parameter types, but different return type, then it is not possible.
Okay, why do we need? There are so many useful areas of method overloading.
Why do we need method overloading? If we need to do the same kind of the operation in different ways, i.e. for different inputs. In the example described below, we are doing the addition operation for different inputs. It is hard to find many different meaningful names for single action. Different ways of doing overloading methods. Method overloading can be done by changing the number of parameters in two methods. The data types of the parameters of methods. The order of the parameters of methods.
Okay, let's make several examples of method overloading. I will start with adding a new class, method overloading. Okay, I will make this class static and I will make it also public, so therefore I can access it from everywhere within my application. And then I will start writing public static methods. Add. Okay, public static add always return double. So the first, let's name it as add. So the first method will take double x and it will return x plus x. Okay. Then the second one will take double x and int I. So it will return x and I, and it will return double as well. So I will write another one as integer. But you see, this time it will throw me an error because the return type doesn't matter. Okay. And also you cannot directly sum double and integer. However, when I change it integer and integer, now it works, as you can see. So I can write another one like this, and now it can use integer I and double x. You see, it is still working because now the order is different and all have the same name. I can define so many different methods like this. This can also have something like this, or this can have like this. You see, with the same method name, you can define different methods. However, the key point is their signature. So the signature is double. Okay. Signature is double plus integer. Okay. Then the signature is integer plus integer. Signature is integer plus double. So you see, the order matters and the parameter type matters and nothing else matters. So the name, so the return type or accessibility level or the static or non-static doesn't matter. What matter is the input parameters and their order. I will write this link to here. Input types and input types orders. Okay. So so far what we have seen, let's note them. Okay, one moment. Okay, lecture 1. How to write a method. What are the accessibility levels of methods, classes, etc. And Oh, okay. The last one is internal. I remembered it. Let me fix it. Okay. So private, protected, public, and internal. Okay. So the last accessibility level is internal. I can make it something like this, and I have to change it. So let's make it double. Okay. So there is also internal accessibility modifier. Internal means that you can access this method within this application, within this DLL. I can export my application as DLL, and then every method inside that DLL can access it, if I remember correctly. So what is internal access modifier? Let's remember it. Okay, internal modifier. Let's read it.
The internal keyword is an access modifier for types and type members. We can declare a class as internal or its member as internal. Internal members are accessible only within files in the same assembly.dll. In other words, access is limited exclusively to classes defined within the current project assembly.
Okay, so accessibility.
Accessibility in same assembly, public, can be accessed by objects of the class, can be accessed by derived classes in other assembly, internal. Cannot be accessed by object, cannot be accessed by derived classes.
Okay, so these are the access levels. I think I can put this link into the application. Let's put it somewhere here. Okay. All right. So what else did we show so far? Initialize. Okay. The difference of static and non-static classes, methods, etc. Okay, I think this is clear. Okay, method overloading. Methods. Okay. Okay. And okay, so let's say you want to return multiple parameters. Can we define a method something like this? Let me show you. Let's say public integer double and string my awesome method. Can I write a method like this? No, you cannot return multiple elements from a method. So how can I solve this problem, solve this issue? How can I return multiple different types of objects from a method? There are several ways. So let me show you each one of them. Okay, let's comment this out. Okay, this kind of return definition of methods are not possible. Okay. So let's say I want to return integer, double, and string from my method. What can I do? I can use tuple. So what is a tuple? Tuple means that tuple is a type that can hold different multiple types. So first solution is tuple. It is so easy to implement. So I want to return integer, double, and string. This is kind of a list. However, it returns single object with the number of elements you have defined. So this can return new tuple. And when I define new tuples, let's say integer and double and result, or let's say awesome. Okay, so when you define new tuple, you have to define it with like this. Okay, so this is a way of returning multiple different type of parameters. This is the first way. Method. Let's see the formal definition of tuples. Okay, so let's see the formal definition of tuple.
C# tuple. The tuple less than t greater than class was introduced in .NET Framework 4.0. A tuple is a data structure that contains a sequence of elements of different data types. It can be used where you want to have a data structure to hold an object with properties, but you don't want to create a separate type for it.
Okay, so usually you can define a tuple with 7 objects and the rest. Okay, an example is here, and so the rest also can get more items, but to access the rest items, you define it like this. There are also nested tuples. You see, for the rest, you can create another tuple like this and another tuple like this. So this is nested tuples. Okay, I will leave this as a description, and now let's see our tuple example. Okay, so how can I use this tuple? Let's make an example. Usage of tuple. Okay, I have dragged and dropped a list box. So it is now taking my entire space on my VPF window. Therefore, first I define an height like this. Okay, now it is more visible. Now I can resize it as I want. Okay. Now add a button for tuple example. Okay. Tuple example. Okay, I will copy and paste the examples here. Okay, something like this maybe. When I double click the button, it composes the background click event of the button. You can also see the click event of the button on its XAML code. Here, you see it is defined like this. So the VPF runs, with the VPF interface runs on XAML here. and there is also code behind. Okay, so first I will get a tuple of my awesome method. Return will be equal to my awesome method, like this. Now, then I will access and add elements to my list box. How am I going to do that? Let's give a name to my list box first. You have to give a unique name to your interface objects first, then you can access them in the code behind. Okay, I will name it as listbox1 items add. So I will use auto format with dollar, and so let's say item1 will be equal to my awesome tuple method return dot item1. Then item2 will be equal to item2, and item3 will be equal to item3. Okay, let's run the application and see. So you can access the elements of tuple with like this. So you see there is no unique names. You have to access them as item1, item2, item3. Therefore, I would say it is not that much useful, explanative. However, there can be useful scenarios for tuples. Okay, it is working. Okay. So let's write 8 or 9 items having a tuple. To do that, I will copy and paste it. Oh, so this is inline definition. Okay, let's write it. And this time it will return a string. Okay, and integer string, integer double. Okay, I can put here string and another integer and string and integer. Okay, you see, it is showing me that this integer is the 7th element of the tuple. Then it becomes rest. So let's make it like this. Okay, so you see it is giving me an error. Why? Because the rest can only be one item. Okay. Therefore, after the rest, you cannot continue. So the rest can be like list integer. Okay, it can be like this. So I will name this as like this and return new. It will automatically type me the return type as the like this. Then I can type my parameters. The first item string, let's say string 1, then integer like this. Let's make it 101, double like this, and string 2 like this, then another integer, then another string 3, another integer, let's make it something like this, and new list. Okay, and the list can be infinitely anything you want. List 1, list 2, list 3. Okay. Okay, so it will return this, and oh, this is the integer list. So I will make the string list. Can I iterate over the return elements of my tuple? Let's try it for each, and I will call my method inside the for each method. Okay, so it says that for each statement cannot operate on variables of type tuple. Let's check it if it is possible. Tuple, okay. Okay, there is no easy way, so I will just give up on that. And now I can add my awesome tuple 2 like this. So you get the idea of the trest. Trest can only be one item, but it can be list, it can be another tuple, it can be anything you want. Okay. So item 1, item 2, item 3, and like this I can add item 4. Okay, you get the idea of tuple, and I can add item 5. Oh, I have to change variable name. I can access the item rest like this. Let's name it as trest, and to use it I will use trest index 2. Okay, and it will be item, or it is named as rest, and since rest is list string, so you see it is showing me the rest, I will access the second item. Okay, and okay, so it says that the last element of an 8 element tuple must be a tuple. So we cannot put a list as the 8th element. Therefore, I will move this list as 7th element like this, and I will make the last element as any generic tuple, it says. So it can be like string. Okay, and of course this will change. List string integer. Okay, string integer double, string integer, and then another integer, and then list string. Okay, and then we will need a tuple. When I say new, oh, it doesn't automatically complete. Let's make it type this automatically. Okay, and okay, and new tuple. Okay, now automatically completes tuple x1 tuple x2. Okay, now as for the x, I can now access it like this, and I can access the list element like this, element 2 as okay, you should give also better names. I am just giving some random names right now. They are not very definitive. Item 7 and okay, now let's rerun the application. Tuples can be very useful and quick to write sometimes, but I would suggest you to use classes. Okay, working. Okay, so this is the first way of returning multiple different type of elements, and the other way would be something like this. So I will write equivalent of this one as like this. List object. Okay, so it will be simply list object, and now by the way, when you use list, the new keyword has to be starting with curly brackets and end with. Okay, now I can use this one as the tuple. You see, it is much more clear. However, now when you return it, you cannot know the returned types. What I mean is, for example, when I type like this, there is nothing. So what can I do? I can access it like this. However, now I don't know the type of the first object. It is string. Therefore, what can I do is I can explicitly write the types. Okay. So it is string. The second one is integer. It can be double as well. It is up to you. Okay, I will write it as integer. And the third item is double. Okay. Double, and the fourth item is okay, another string, and then I will write the second element of the list as it is a list, as you can see here. It is the 0, 1, 2, 3, 4, 5, 6th index. You know that the arrays and the index of arrays starts from 0 in C#. Then I will access its index like this. However, to be able to access it, I have to convert it as string list, and then I have to put another parenthesis, I believe. Okay, so you see it becomes much complex here, and the same rule will apply on this one as well. Okay, so this will be a tuple. This is a bad programming, but to be able to show you, I am doing it as an example, but this is a bad programming, believe me. And this will be the one. Okay, we have some problem with the, okay, here. Okay, now you see, oh, it says that it cannot convert object. Oh, I know the reason. I know the reason because I have to define the index of the item, which is 7. Okay. Now, you see we have written the both functionality in the different ways. Now they are both working as expecting. Now the third way would be defining a custom class, which would be my preferred way. One moment. Okay, the third and the proper way is defining a custom class with the desired parameters. So let's define a public class, and the class name, our grade class. Okay. And so which parameters we need? We need a string. For that I will use prop top and I will write it a string and as our first string. So what is the difference between get and set having string and this string? Okay, so meanwhile this is being a property, this is just a field. And there is a difference between fields and properties. You can overload and change how the way properties works. However, the fields are just fields. Okay, so let's see about the field and property difference. So I will write this custom property. Okay, and the get will be, the set will be, let me show you. Okay. Okay, so for custom properties to work, we have to keep a private variable like this, which will be only accessible within this class. Since this is private, it can be only accessed by the methods inside its parent class, not from the parent of parent class. Only the direct parent class can access private elements inside that class. So let's name it as property like this and this. So when it returns the name, it will append date time in front of the name like this, and as our custom property. And when we set the name or the property, you see this is the get. Get means that whenever you access the property, it will call this method. This is actually a method. Okay. And this is also set. Whenever you set the property, it will be set like this. I can make it equal to value, or we can make an addition to the values such as to uppercase. Okay. And inside the upper, okay, let's make it just upper. Okay, and I will show you the difference of get and set method. Okay. And what else we need? We need an integer. I will make the integer first integer as field and the second integer as property. So as for the field integer int ir1, by default integer is 0 and by default string is null. Null by default 0. And then we have double. I will make the double as field 1. Okay. By default double is 0. And then we have the string 1 and string 2. First string, second string. Let's change these as first integers. Okay, first double. And then we have the second integer. So the second integer will be a property as well. Second integer. And to keep it private int second integer, and for get and set method, okay, like this. And okay, when we return the second integer, I will return 10% of the integer, and when I set it, I will set it as value plus 5. Okay. So you will understand the difference. And there is third integer. So the third integer will be by the way, it has to be like this. A default property. Integer third integer. So it will have the default get and set. And then first list. It is a string. First list, and I have to initialize it like this, so it will be an empty string list. When I initialize any instance of this class, this string list will be also initialized as empty list. So by default the list will be null, and then finally a tuple we have. So public tuple string and first tuple, and okay, I won't initialize, so it will be like this. I won't initialize this as well. I will let it by default null. By default I think the tuples are also null. But let's verify it. Okay, then I will verify it with debug. Okay, so let's compose an instance of our class like this, and I will name it as like this, or let's say custom class. Or actually we can define a method and it can return our custom class, something like this, private what is our class name? It is our grade class. So the return type is grade class. Return grade class. So it will take nothing as parameters, and it will return new or grade class. Okay, so this will return a default instance of the grade class, something like this, equal to return grade class. So let's see the default of my grade class. I can use the var keyword as well. So the var keyword is being an instance of, you see, under namespace lecture1, under main window class, it is our grade class. Okay, let's put a breakpoint here and let's see the default values of our grade class. Okay. So by default, our class is null because classes are reference types and they actually have no value by default, therefore they are null. We will see about reference types and such in future. And I move one step and now I can see the default value. So you see second integer. This is private, therefore I can only see it in debug mode, but I cannot access it from anywhere. It can be only accessed within inside of this class. Okay, so these are the private values. You see 0 and null. Then first double 0, first integer 0, first list null, it's a list. First tuple, by default it is null. And these are the properties, as you can see. So the custom property, it is by default a datetime. When we read it, even though our value is null, and first string null, second string null, third integer 0. Now I will initialize my values. So how can I do that? I can do that like this. You see first double and with semicolon, I can define it something like this, or equal to, yeah, equal to. Then first integer will be 99 and first list will be new. I have to use new and initialize the list as grade list 1 and grade list 2 etc, and then first tuple equal to new tuple and let's name as tuple 1 and tuple 2, and then what else we have? Second integer as 1000 and the custom property as, let's name it as programming, and then we have first string or let's name it as school, and then we have second string as second, and then we have the third integer as like this. You see, now I can give sense making names to my variables like first double, first integer, first list, whatever. They are not item 1, item 2, item 3, or like here without anything. So when you define a custom class, it is the best way, and now I can add it to my list box. Let me show you how much better it will be, much easier, better, and readable. When you write a code, your code has to be readable. It is extremely important. And okay, so let's start. So our first variable will be, let's say, second integer. You see, I can put any variable with the name itself, so I will type this as second integer Then I will put a top character, or let's put comma. Then the another item will be, let's say, first list. Okay, so first list second item, so index 1 equal to like this is the second item. I can say also like second item of second object of first list. Okay, by the way, if your list doesn't have two items, then this code would throw an error in the runtime. Can we prevent it? I think yes, we can prevent it with list overloading. However, it is a more complex thing. So I don't know if there is a null check like this. Yeah, let's try it. I wonder if this will work. So we don't have 11 items, therefore if this null check works, it should not throw an error. Oh, it is throwing an error. So this null check is not working. Okay. So what can we do? Maybe this, but I'm not sure this would work. Let's try that. Not either work, not working as well. C# list index null check. Okay, no easy way. No easy way. Maybe this can work though. Let's see, element at or default. I have never used element at or default. Okay. Oh. Oh, here. Okay, let's try like this. So I wonder what kind of result it will produce. Probably it will be null, I am assuming. Yes, it is null. Nice. So it didn't throw an error. Therefore, with this way, by default, it will be null because it is integers. It is string list. So let's compose an integer list. And let's name it as second list. Okay, now let's initialize the second list as new list, and okay. Okay. Two and okay. I think these are still zero based index, and then to show you the meaning, second list now we will see the difference of default values of string and integer. Okay, so the second object of the first list is empty. Okay. And 11th object of the first list, I mean the second object of the first list is grade list 2. Let's see it if it is true. Yes, grade list 2, we can see it here. This is the second object. 11th object of the first list is nothing, because when you convert null into the string, it becomes nothing, empty character. Then the second object of the first list, second list is 12356, and we see it is true. And the 11th object is 0, because the default value of an integer is 0. Meanwhile, the default value of the string is null. Okay, it is working as expected. Now let's see our modified custom property. Okay. To test it, let's add another line into our list. So the custom property is programming. We set custom property string expected, or let's say given value, or let's say set value is programming, and let's see the output of the reading. Okay. So when we read it, what do we expect? We have set programming as value, and when we check our code, we will see that when we read it, it will return the set value plus date time now. And when we set the value, it will convert it into uppercase. So we will see date time plus empty character plus uppercase of programming. Let's see if it is the way. Okay, custom property string set value is programming, and returned value is you see date time, empty character, and uppercase of programming. So this is what is about having properties with custom get and set methods. Okay. Basically, we are overloading the get method. Overriding basically the get method, and we are overriding the set method. You may not understand this right now, but over the time you will understand it. The same rule applies for integer. So let's see the integer as well. And for the integer, we did set as our second integer, yes. The set value of the second integer is 1000, and let's see the output value. So when we set 1000, it will be set as 1000 plus 5. And when we get it, it will return 5, because the 10%, actually this is not the percent of not the percent we take. This is named as, I think, this is named something different probably. Okay, this is modulus operator or reminder operator. Yeah, this is the correct naming. Reminder or modulus operator. So we will get 5. Let's see. And I will also check the values from debug window so you will understand better. Okay, let's see the screen. I run it. Click continue. Okay, so you see the custom property in second integer set value is 5, however displayed value is 5 as we guess it. And let's see from debug. When I hover my mouse, my cursor over my class instance, I can see you. So you see the private value is 1005, however read value is 5. Because when we are reading, we are applying the rewinding operator 10, and when you divide 1005 to 10, the remaining value is 5. It is same for custom property. The value is programming. However, when we read it, it is date time plus programming. Okay, so how to with fields properties. How to compose a okay, let's see formal definition of fields versus properties in C#. Okay, let's read it.
Differences, uses, when and why. A field is a variable that is declared directly in a class or struct. A class or struct may have instance fields or static fields or both. Generally, you should use fields only for variables that have private or protected accessibility. Data that your class exposes to client code should be provided through methods, properties, and indexers. By using these constructs for indirect access to internal fields, you can guard against invalid input values. A property is a member that provides a flexible mechanism to read, write, or compute the value of a private field. Properties can be used as if they are public data members, but they are actually special methods called accessors. This enables data to be accessed easily and still helps promote the safety and flexibility of methods. Properties enable a class to expose a public way of getting and setting values, while hiding implementation or verification code. A get property accessor is used to return the property value, and a set accessor is used to assign a new value.
Okay, so you see this is a very good answer, and I will show you what they mean of value checking. Okay, so it says that with properties we can have value checking. What does that mean is, let me show you. Let's assume that you have a volume control of an application. Okay, volume. Let's name it as IR volume. Okay. Safety check, or let's say so a volume can be between 0 and 100, right? So what we are going to do is we will do like this. We will assign value to volume, and then if volume is bigger than, if volume is greater than 100, I will return 100. If volume is lesser than 0, I will return 0, else I will return volume. So you see, now I am having a control at the get method. I could do this in the set method as well. However, both works. So let's print some volumes. Okay. Let's show example. Okay, look, first I will set it to volume as something like this, and volume. Okay, then I will set it to 55, then okay, something like this, and then so you will see the difference of set and get. Volume will be equal to that's something like this. Okay, so what values do we expect to see? Okay, let's run the application. What values do we expect to see? This is something hard to guess, I would say. So first we will see 0. The value will be set privately minus 321. This one will show 55. The value will be set as 55. This one will show 100. The value will be 1554. This will show 0. However, the value will be minus 1154. Okay, so here the private value will be different. So let's see 0, 55, 100 and 0. And let's see the private values of the last example or each example. Let's see. Okay, private value 21, private value 55, private value 4, and the private value will be this. Okay, so let's see. Because when it is going to do an addition, it will read its current value, and when you read the current value, it will be read as 100. Okay, because it cannot access the private value at all. Okay, so the private value is, you see, minus 321. Okay, the private value is 55. Okay, the private value is 1554, and now the private value is 1154. Why? Because when it is going to do an addition, it will read the value, and when it reads the value, it returns 100, not 1554. Okay, so this is about fields and properties, classes, and instance having objects. Since this was an instance-based class, we define an instance of that class, and then we can set its values. For example, I can compose another class instance, my grade class 2, and it will be initialized like this, and I can set its volume as 24, and then I can write the volume of total volume plus this. So what would be the total volume in this case? So this is initializing another instance because we are using the new keyword here. The new keyword is important because it creates a new instance. Okay. And it is used for initialization of objects, a new instance of objects. All right, and so what would be the output? In this case, the output will be, in this case, the first volume will be 0, the second volume will be 24, therefore the total volume will be 24. And we will be able to analyze each instance unique value. So as you do programming, you will understand the concept of instances and static variables. Okay, so you see the total volume is 0, 24. Do you know why? Because inside listbox, it has converted these into the strings, then printed them. Okay, and the second case will be like this. Okay, output is 0, 24. Output will be. So you see the importance of parentheses when working with C#. In this case, in here, first the .NET compiler convert this into a string, then do string concatenation. Okay, but here it will do a mathematical sum, then it will convert it into a string. Okay. So basically this is equal to first way is equal to below way. This one is equal to toString and string. Okay. So you see this is same as this one. Let's run the application. Okay, 0, 24, 24 and 0, 24. Okay, let's dock this here. Okay. All right, so for the first day, first lecture. Okay, I think at the home you should make some other examples of what we have seen so far, like method overloading, void return type, custom class return type, tuple return type, private, public, static, instance of members, static methods, and such. And when working at home, do not just copy and paste my code. Try to type it yourself. It will help you tremendously, believe me. And let's see. Okay, I think it's enough. Now I will upload this to our repository. You can also learn it, how to make it. So let me just copy and paste git ignore. I use this for to exclude some folders from pushing, and I will make it as source codes. Do we need source codes? No, we don't need source codes, I think. Let me check how we did. Yeah, I will make it. Okay. 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 And let's upload it to our GitHub repository. So our GitHub repository has a README. First, I have to pull it. Okay, I have to run it from here. Okay, and okay, Git status. Okay, it is not a Git repository at the moment. So first we init it. Okay, git add remote origin. I don't remember the exact code, but it was something like this. Git remote add origin. Okay, now I will pull. Okay, now git add all, git commit lecture one, and now I should be able to push it. Okay, okay, so when I refresh it, source code should be here. Let's see the message. Create a pull request for master on GitHub by visiting. Interesting. Ah. Why it didn't work? Okay, it says everything is let's force it. Okay, yes, origin is looking correct. Okay, sometimes it is harder to get it done correctly. So let's just save this into our repository. will delete the git. Okay. And then okay, and okay, now we should update. So what I did was I have reinitialized the Git repository with README, and then I did forced update, as you can see, and because it was an empty repository already. Now we should see our code here. Let's refresh. I don't understand why. Because we are on the main branch, we have to incite the master branch. But this is not what I want. I have to delete the default branch here. Okay, let me change the main branch. Uh, okay, I will delete it myself. It is not a problem. Okay, I will pause a bit. Okay, I have fixed the branch and named it as master. Now I will push again. Okay. Okay, now you see the lecture 1 source code edit, and we have updated README file. This semester we will be using Discord as well. When you click it, it will join you to our Discord channel. And please make your username as your real name. This is my another account, and you can right click and change nickname and type your real name like this. And then you should join our new course channel. It is not here yet, but hopefully it will be very soon here. So when you are watching this video, very likely you will see the joining number here. For example, when I click 5, it will make me join this one. You see, when you join any of these, you can see the new channels as well. They will be also join based. So our course related things will be posted here. You can also ask your questions on the general channel as well. I will keep the previous channels as well, so you can also look for them. If you want to remove yourself from certain channels, you can leave the channel and rejoin. I will be leaving right now. Okay, if you have any questions, feel free to ask me from my email or from Discord. Both is fine, and hopefully see you next week. All right.